Of Eden Irrigation, and I'd like to tell you about these potatoes. All of their water and most of their fertiliser was applied with Netafim drip irrigation technology. And this is how we do it. This is potatoes. They've been planted about a week, 10 days. There's no canopy there. If you were to put a rain gun in here now, you'd just wash the field away. We're laying a Netafim drip line. This is a 20mm diameter drip line. Has drippers every 40 centimetres, and each dripper has a flow rate of 0.6 litres an hour. And we're laying one of these drip lines on every bed down the centre. We brought in the crew, the machinery, we'll come in and lay it. I mean, this site will take us 2 days. We come in, lay it, connect it all up, make sure it's operational, and then the lads will move on to the next one. I mean, this was obviously potatoes are grown as part of the rotation. This crop is destined for walkers. If we weren't doing the drip work here this year, they would be using a rain gun on this to irrigate this field. Now, all of this field has had approximately 20% of its nitrogen applied already. On half of the field, we will put the rest of the nitrogen through the drip. On the other half, they will add nitrogen as they would conventionally, broadcast it on, spin it on. And so later in the season, we should see some significant differences between the crop. A new product by Netafim, 2 years old now, I think, Flatnet. It's a unique product. It's a polyethylene lay flat. But the unique part about Flatnet is that all the fittings are welded in at manufacture. So we've got no assembly in the field. No tape, no sealant, it's a self-sealing joint, and we just put our tape connection in. Compared to a polyethylene system, the cost as an installed product is significantly less. The time on site is considerably less. The jointing mechanism on it is very simple. This is a big revolution for us. They get a more consistent, uniform crop. Some people will see significant fertiliser savings, some will see water savings. There's no solid baseline, so it really depends how well you're irrigating at the moment as to the potential water savings that you can make. The handling system, the drip is delivered on these metal cages. There's 4,500 metres of drip on each cage. Fix it at one end, and then they drive away, all the drip comes off. They get to the other end, they cut it, and then they turn around and come back again. If you look down this tube, you can see the dripper, which is the Netafim Drip Net dripper. These are positioned every 40 centimetres. Each of the drippers has a flow rate of 0.6 litres per hour. Now, all of this area is a filter, an inlet, so any dirt that does get past our primary filtration, our secondary filtration, and still gets into the drip line, has a filter there to stop it getting into the dripper. Now, the labyrinth is the key to the dripper's success. The job of the labyrinth is to take the energy out of the water and to make it drip. We will have half a bar at the far end, and the diaphragm will be depressed to a different level at the far end than it is at this end. But each dripper, each outlet will still be giving us 0.6 litres per hour. Now, above that, we have a diaphragm. Okay, it's an injected silicon diaphragm, so it's very resistant to chemical, and this would sit above the labyrinth. And what the diaphragm is doing, on its top surface it has the high pressure, the 3 bar. On its lower surface, in this chamber, it has 0 pressure. And so the diaphragm is regulating the output. It's pressed down against the orifice. Basically, all we have to do to this section now is to put the valve in and the filter system in, and this is ready to run. Okay, we're just about to start the system up, so we're going to turn on the water from the farm's hydrant system. Now we have water coming into the filter, an Amiad filter mat, fully automatic self-cleaning system. Inside the filter we have a suction scanner which runs on the inside of the screen. So if the filter starts to block, and we get more than half a bar pressure difference between the inlet and the outlet, the filter will automatically clean itself. We then have the flow meter where we'll record the amount of water that's gone into the drip. This will be linked to the control system, so the feed is injected proportionate to the flow of the water that's going through the system. Now we can turn the valve on and release the water to the field. There'll be one valve for each drip section, which will be linked to the fertiliser system when it's installed, so they'll be completely automatic. Once we've started the valve and got water running in the system, we let water run to the ends with the ends open. Now this allows the dirt to be flushed out of the system, and then the lads just seal them over and seal them off, and the system is then sealed, ready for the season. This field is 400 metres long. We're running 6 hectares of drip lines, and to do that we only need 2 bar pressure. This drip line can be run to a maximum of 3 bar, so we could go probably another 100 metres further. Compare that to a rain gun. A rain gun would typically run at 8 bar, so we're running the system at a lot lower pressure, which means if you could run your pumps at lower pressure, you would use less energy, less electricity, and a system that's not so susceptible to breakage. Okay, good morning. It's now 6 weeks since we did our last filming in Thetford. We're now in Stafford, and we're looking at another crop of potatoes we've been drip irrigating. It was planted the middle of March, so it's significantly further ahead than the last crop we looked at. So this site is split into 5 irrigation zones. Visibly, the amount of water applied through the drip is considerably less than being put onto the rain gun. We have our aluminium pipe, which is fed from the diesel pump by the river, and then we come to the control valve. The control valve is linked to the central controller via a radio. And from here we can control and measure the amount of water that goes on and the amount of fertiliser that goes on, and we run all the valves. On this site the grower is bringing the liquid nitrogen, which is a 30% UAN, to the field in 1,000 litre IVCs. Our system is then sucking out at the top of the IVC. We're feeding on a weekly basis, and we have a feed program that the grower is following. But basically we program into the computer what we want to apply. It then measures it, applies it during the irrigation. In the event that we had high rainfall and we didn't need to irrigate, we would still apply the nitrogen. And we can apply a week's worth of nitrogen probably in about 30 minutes. This is the rain gun area. About 2 hectares, runs about halfway down the field of rain gun crop. So if we have a dig and see what we've got underneath, and we can compare this with what we've got under the drip irrigated crop. Here's our rain gun crop so far. We'll go down to the drip now and dig a sample there and see what we can see. Although we're not putting water all over the bed, the crop adapts to where we are adding the water. Okay, so if we lay the sample, we can see in general the variation between the tuber sizes is less with the drip than it is with the rain gun. The plant has adapted to draw the water and develop the tubers accordingly. This part of the field is about 700 metres long, so it's too long to feed from one end with a drip pipe. So here we have a centre headland, and we're feeding both ways. So you can see our drip header, and we're feeding 350 metres one way and 350 metres back the other way. Part of the aim when we design these systems, we lay these systems out, is that we maintain field access for all other operations. So all we've done is we've laid a very simple duct under the track with the drip lines in it, so the drip lines are protected and can be run over. This field is a an odd layout, inconvenient layout, especially if you're using a rain gun. There would be a lot of different irrigation pools on here. I estimate it would probably take one machine, something about 3 days to get across this field. Good morning. We're in not so sunny Norfolk. We're going to go and watch the crew pulling the drip lines out today, ready for the crop to be flailed and harvested. We're also going to go and look at another field that's currently being harvested. So it's the end of the potato story. They come through and have chopped all the tops off, flailed it all off. It stops potatoes growing effectively. Alright boss, how are you? So basically off the trailer, graded, washed, and then loaded in a wagon to go to Orcas. The site we're going to go and see where they're reeling the drip up, the crop will actually be stored crop, so it won't actually be washed and loaded onto the wagons till next May or June. Here we are in another field. This time we're in North Norfolk. This crop, as you can see, is starting to senesce. Crop's destined for storage and it'll be harvested in about 3 weeks' time. We've got 2 jobs left, picking up the drip pipe and picking up the headers. The drip pipe is a 10-year product, so they'll pick it up because this field won't be potatoes again for another 5 years maybe. So they'll pick the drip pipe up from here, be stored over winter, and then wherever they plant potatoes next year it can be relayed, reused. If we just have a look down this sprayer wheel in here, I mean this is typical of a rain gun irrigated site. Yes, it's a small area that's damaged, but as part of the efforts that these farmers make, investment in minimum travel techniques and trying to keep as much machinery off the land as possible, this is all detrimental to production. We're just picking up the flat net drip line header. All the fittings have been taken out. Now this first part of pipe wasn't actually used in this crop. The way we set the systems up is that we use a 100-metre coil. We don't cut it to length because it will never fit a field the same. So we leave it as a 100-metre length. We've sealed it off in the middle, so we've got to go and break the clamps in the middle. And then it'll all be wound up back onto this coil for use next year. These potatoes ended up as crisps, but could have easily been any processed potato product. Wherever you are in the country, whatever your soil type, we can make Netafim drip technology work for you. Netafim gives you greater yields, saves you water, saves you fertiliser and pesticides, thus saving you time and money. All of which ultimately gives you a significantly greater return per hectare on your processing potato crop.